Hello. The project we've been working on over the semester is an online appointment scheduler. My name is Christopher Gore, and I've been working on the user interface design for the student side of the project.
My name is Madeline and I've also been working on the user interface. We've been using HTML and CSS to design all the web pages that go along with our project.
My name is Christopher Schayer, and I helped design the functionality that goes into allowing the student side to properly work, as well as the layout that the data is stored on the database.
My name is James Singleton. I developed the server for our project as well as the database.
For the project we've been developing over the semester, we have been building an online appointment scheduler. The purpose of this was to help the students and the advisors come up with a way of scheduling appointments. The scope of the project was meant for the computer science department. However, it's capable of being extended out to other departments and other colleges.
The vision we had for this project came from the lack of a system in place in the computer science department. Many other departments at this school have online schedulers, which makes it very convenient for both the advisor and the student. Right now, for the computer science department, students have to email the advisor and request a time, but this is very inconvenient because by the time the advisor gets their email, that slot could have already been taken. And so it just takes a lot of emailing back and forth between student and advisor and creates a lot of frustration for both. So we wanted to come up with an efficient yet professional way to solve this solution. So that is how we came up with our online scheduler.
One of my responsibilities for the website was building the database. For the database, we chose to go with a MongoDB database, which stores items as documents as opposed to in a relational database. So I was able to find the website MLab, which allows us to host a MongoDB database for free for a small database. This is the database we set up for testing purposes. In this database, we have two collections. We have the advisors collection and the appointments collection. So we're storing the individual advisors and then the appointments scheduled for those advisors. The appointments would be scheduled by the students on the website. The advisor would be the login and the advisors that can use the website. So let's go ahead and take a look at the advisor collection. So this is an example of what's in our advisor collection. We have the database ID, username, password. Right now we're just storing the password as strings. That's not how we would have it when we deploy the actual website. We would hash those passwords and increase user security. But this is just for testing purposes. So we have the name and the days they're available during the week. Now anytime a student would schedule an appointment, that would move a time from the available array to the unavailable array, and it would then display that on the calendar so the student could not schedule an appointment at that time. So let's take a look at the appointments. So this is an example of what's in the appointments collection. As you can see, we've got multiple appointments, days, times, the service for that appointment, the advisor scheduled, and the student who scheduled the appointment. So let's take a look at one of those. So this is an example appointment document. As you can see, it still has the unique ID for each individual appointment. The day, the time, the service, the advisor, the student, and the student email. So that's how we're storing those appointments. They each have their own individual document for each appointment. So that's it. That's the basics of how the database is set up, and that's what we're using for the website.
Development of the software was conducted through the IDE WebStorm. It worked well in conjunction with GitHub, which we use for version control. The reason version control is obviously important is because this was our first experience working in a team environment, and being able to see what changes and being able to revert back if any errors in our code occurred seemed very paramount. Reason we use GitHub though was because it has a very easy to understand interface. When you push your project onto GitHub, it'll have it in a layout of all the folders that you have set up in your project, as well as README files that you can create that will allow the users to understand how to operate said program or whatnot. GitHub also has other functionalities like being able to see how often your employees or team members are sending new code in, as shown here. with this punch card, they have graphs that just simply show on this past Sunday we had several code pushes, as well as other days in the weeks, as well as the time hours. The other great function though that GitHub does offer is as versions are incremented and new versions of the software are pushed, you can actually reference previously updated software just to see what changes were made from the past version to the current version. Using this one, for example, this file is the JavaScript that runs the student side of our online appointment scheduler. As you can see here on this layout, any green highlighted lines were lines that were added into our code. Any red lines were lines that were deleted from our code based on the version. And also, as each new version is updated, you can also attach comments to the files that state what exact changes you made, or maybe in a general case, what functionalities you may have added or removed since the last version. And that's essentially what we chose to do for our version control. And that's about it.
Hello, this is James Singleton, and I'm going to demonstrate the functionality of the advisor portion of the website. One of our original use cases was for an advisor to log into the website and be able to view their appointments. I'm going to show that we have accomplished the main part of that goal, as well as discuss some of the elements we have not implemented yet and are still under development. Before I get started with that, I'd like to briefly discuss the IDE we use for this project. The IDE is called WebStorm. It was a great IDE for our project. It was easy to use and had great version control integration, integrated well with Git and GitHub. It allows us to easily push changes to our GitHub repositories, as well as pull in changes for our team members made. So it really made collaboration very easy for us. Now, my main role in the project was building the server as well as the API. For the server, decided to go with Node.js. It's a runtime environment that allows the JavaScript to be written on the server. It's really becoming very popular because it's fairly easy to use and allows you to write JavaScript on the server as well as have JavaScript for your web pages, which has the benefit of being able to use one language for both sides. Now, Node interprets JavaScript using Google Chrome's V8 engine, which was built in C++ and compiles JavaScript code to machine code, which makes it pretty fast. And now Node.js is open source, so it has many great open source frameworks that are available for use with it. One of the main ones I use for this project is called Express. Express makes building a server a little bit easier and gives you a lot of great functionality there. So I was really happy with Express. In fact, the stack we used for this project is known as the mean stack, which is MongoDB, that's our database, then Express, AngularJS, and Node.js. Now, it was really a great stack. It's becoming pretty popular because it's easy to use and can make great web applications with it. I plan to continue to use it in the future, and I look forward to learning more about it. Now that we've briefly gone over some of the technologies we used for this project, let's take a look at our demonstration. So here we are at the home page. I have the server running. As you saw back here, app listening on port 3000. If I wanted to stop the server, I could stop it here, and then we could restart it. There. Okay. Let's see, refresh the page, so it comes up. So alright, so let's pretend we're an advisor, and let's go ahead and log in and show how the website works. Click Advisor Sign In. That's going to take us to the Advisor Sign In page. Now we have this basic form here, username and password. Both fields are required, as you can see here. So now if I enter some wrong information, we'll see it will not let me log in. At this time, the attempts for login are unlimited. This would obviously be something we would change when we deploy the project to allow for better security. One of the things that we did not have time to implement was right now we're verifying users based on just strings, checking their passwords are stored as strings in the database, and we're checking those strings, which is not a very secure way to do things. Ideally, those passwords would be hashed, and we would have better user authentication methods. There's actually a good open source framework called Passport that I had planned on implementing, and just due to time restrictions, I was not able to do that. So right now, we have very basic security, which is something we would want to upgrade in the future. I'm going to log in. We have two test advisors, John Doe and Jane Doe. I'm going to use John Doe. So JD. Pass is the password. Not a good password there, John. And we log in, and we will see John's calendar here. This is the calendar for this month, and as you can see, these are the current appointments John has. Let's see, we have Kate Smith here. Now we're currently using military time. This is something we could change. We just left it there for convenience. 2 appointments here, and then 2 here, or 1 there, 1 there. As you can see, we have multiple views for the calendar. We can see all the appointments for the year. These are just test appointments we have in the database. And the month view, as we saw, see only appointments for this month. We haven't entered any for next month. This week, and then today, no appointments. Tomorrow, just 1. And there. Now, in our original use case, we had talked about implementing an alternate list view. This was another feature we just didn't have time to implement. We got the calendar working. The list view was something that was one of our goals, but we just haven't finished it yet, and that is still under development. Now, from this calendar, the advisor has the ability to view the appointments here, and as well as delete them. So let's delete one. All right, let's see, Jim Anderson. We will click this, and Jim's appointment is gone. Now, what we had in mind for the project was the appointments hold the student's email, and anytime an appointment is canceled, we would send them an email. Now, we had debated over which way to implement this. We weren't sure if we wanted the advisor to modify the appointment or have the ability to do that, or just cancel it and notify the student. We decided to go with the cancel route because that way the student would be notified and they could go back to the sign-in and pick a time for a new appointment that was convenient for them. The email is something that is still under development, which is just a feature we haven't gotten to yet, but that is something we will develop in the future, would be implemented. So that is the basic functionality of the advisor side. As you can see, we have accomplished our main goal of creating a website the advisor can log into and view their appointments. I hope you've enjoyed this demonstration, and thank you for your time.
Hello, my name is Christopher Schayer, and I will be demonstrating the student side of our online appointment scheduling application. This demonstration will illustrate the use case in which a student would schedule an application with an advisor of his or her choice. The student side of our application was built modularly to create each component dynamically based on the database of the advisors that were choosable, the reasons that were provided, and the available time slots. It's also designed to show and hide each component as necessary as the student completes the tasks in which he or she goes about scheduling the appointment. So to start, the student will be prompted to select a counselor from a list that is populated via our database in MLab. We only have, for this demonstration, 2 dummy counselors, a Jane Doe and John Doe. Upon choosing the counselor, another drop-down box will appear prompting the user to select a service that will better inform the advisor on why the student would want to schedule an appointment with them. This will allow for easier advising sessions to just smooth transition. After clicking the select a service box, the mini date picker will appear, allowing the student to then choose the current available days, which would be the current day, and then each following day between Monday and Friday, because advisors will normally advise between Monday and Friday. This option can be easily changed, though, in the code to fit whatever need the business or school would need to or have advisors available. So I chose the current day today, and as of right now, because we do not have an online server that's running 24/7 and can't auto-update the current days, we've hard-coded just a week for this demonstration. So the calendar will appear with the available time slots for said counselor. The student will look through this list and see if any of the available times will meet what they need. If one of the times meets the student's criteria, then he or she will then choose the time and will be prompted with the appointment overview box. This is where the student will fill in the parameters of their name and student ID. This will allow the advisor then to look up any information relative to that student via maybe grades or anything for their college or whatnot. That'll work. Entering just a student ID in here, the student now has filled in all the parameters and will hit submit. As you can see, once I've submitted the appointment, the appointment time has now been removed from the screen. The student is no longer able to click that time and schedule an appointment. That appointment has now actually been pushed to our server and has updated via MLab, in which now the advisor can see the appointment I just scheduled. Thank you very much, and I hope you enjoyed the demonstration of the student side of our appointment scheduling application.
As you can see from the demonstration of our product, we were able to meet the vision in creating an online scheduling application that not only was easy to navigate, but intuitive for the users to know how to schedule an appointment. In future versions, we would hope to add greater functionality that would allow users an even greater ease of experience, as well as perhaps give more organized presentation of data on the admin side. In the future also, we would want to scale this project to meet any business environment to allow for large-scale calendars for multi-corporations or just large clientele base. Thank you very much, and hope you enjoyed our product.